everyone, this video is about integration, Pure 3, Paper 3, past paper questions. Number 1, using the expansion of, so we're going to focus on the integration here, hence show that. Okay, so of course we use the answer to the previous part, or this identity here, and yeah, you can just integrate directly. The integral of cos is sine, and remember that we have to divide by 4 here because of the 4x, and we have to divide by 2 because of the 2x, and we can replace the x with the terminals, the pi over 6, replace with minus pi over 6, and use a calculator. You get this. You can simplify again using a calculator, and you get the final answer. This is just all calculator work. Alright, now let's try something else. Yeah, let's try the partial fractions questions. So this is what you get for the partial fractions part. So we're just gonna use this. So using partial fractions, we get this integration, and for minus 1 over x, that's simple, minus ln x, and for 3x to the power of minus 2. So for this part, it's better to write it in this form because the integral is, using the power rule, and this is just using ln again. Plug in the terminals 4 and 1, plug in, and use your calculator, and you get this, and you can use the log rules to get this. This is showing question, so your final answer is not important at all here. The process is important. Alright, partial fractions. Now the integration by parts. Yeah, we have to identify the u and the dv. The u is ln x because we can find the du, or we can differentiate. Now if you choose this to be the dv, it's just complicated to integrate ln x. So we use ln x to be the one we differentiate. This is u, this is dv, u v minus v du. The v is the integral here. The integral of x to the power of minus 3 is this. And then yeah, you can simplify, and the integral of x to the power of minus 3 is again this. And then we can simplify, plug in the terminals, and use the calculator, and we get the answer. Remember, it's gotta be in the exact form. Alright, next, by parts. This is also by parts. This is also by parts. By parts twice here. By parts, substitution. Okay, so for the substitution, find the area, which is the integral from 0 to pi over 2 of the function sine 2x cos squared x, and using u equals sine x, du dx is cos, so dx equals du over cos, and the x is from 0 to pi over 2, sine pi over 2 is 1, sine 0 is 0. So now we replace sine 2x with 2 sine cos first, and after we multiply cos times cos squared to get cos cubed. The sine x is u, so we substitute here. The dx is d over cos, so you can cancel out 1 cos, and cos squared is the same as 1 minus sine squared. Sine squared is again u squared because of the substitution, and then 2u times 1, 2u times u squared. Wait a minute, 2u times u squared is u cubed actually. Yep, this is actually u cubed. So 2u times u squared is u cubed here, and so we get the integral is 2 over 4, so 1 over 2 u to the power of 4, and we plug in 1, we get 1 over 2 actually. So 1 over 2, this is also to the power of 4, and this is also 1 over 2, and this is to the power of 4, and 1 over 3 is, 1 over 2 is the final answer then. Right, that's it for this substitution, integration, substitution. Right, that's it. I'll see you again next time.